everybody. A little about me. This is Vincent from Ampere Computing. So I'd like to thank you, GIGABYTE, giving this opportunity to give a presentation for 13 minutes. Today's topic is, well, not AI related. I know AI is a very hot topic this day, but today is more like a serious topic regarding the ESG, about the carbon dioxide emission. So how to use the new technology, new processor from Ampere Computing to do the carbon dioxide emission reduction. So let's get started. All right, a little bit background for Ampere Computing. Ampere Computing is a new company starting at 2018. Our CEO, Renee James, was former the Intel president and retired from Intel since 2015. Then she is the visionary to see the computing industry need to have a revolution and for a new future. So she found this Ampere Computing since then. Okay, then we kind of focusing on the modern cloud data center and service to design a new processor for the future. So talking about the CO2 emission. So recently we have a lot of global warming issues. It's getting serious. So a lot of wildfire happening around the world, and you can see the those iceland collapse, and the polar bear is kind of as a dangerous species. So if you see the data here, actually you will be very shocked that the data center actually contribute like 3.7% of the CO2 emission around the world. Okay, in compare with the other data, for example, like aviation, the plane we are taking every day contributes like the 2.5%. Okay, and shipping is about 2.5% as well. And you will be amazed, like the risk calculation is also contribute 1.5%. And the tobacco and the food processor also contribute a certain like 1% all the CO2 emission. So why the data center is still growing? So if we don't do something right now, the emission will be all the way jump to the 5 or 6% or even higher, right? So we need to address that with the new technology for the future. All right, let's go back a little while reviewing about the computing progress. In the back, like 1960, that's a mainframe computer era. So you can see that's very, very big stuff. It's very expensive. So only a few can afford of that, such as like NASA, such as like IBM or those very rich or big corporate can afford of a mainframe computer. So the overall number for the main computer is very limited. And then everything goes, the technology evolved that the client server will become the popular because a lot of time Intel can offer their CPU, there's a laptop, there's a desktop, the Windows, all of that. So it's become affordable. Then even a small enterprise or company, they can buy the server, they have many desktops for daily use. So the overall value is getting bigger. And all the way to the 2010, a lot of time, right now we have a smartphone, we have all the portable device, and the service also change. Right now, we are in the so-called cloud age. Then all the microservices we are running at this point at your handphone, your laptop, everything. Then this connect everybody all together and provide a lot of need service. Our daily life is more convenient. Therefore, the volume overall is increased dramatically. Therefore, we need to have a lot of server to service all the microservice service over there. Therefore, that's it's gonna consume more power. and build more data centers. So that's the all the computer evolution. Then that's how I view when we design the CPU. We look at like a core data center, how this performance is asked by them. We design the core, our CPU with multiple cores up to 128 cores, and even more in the future. And for the performance-wise, they're asking, okay, speccing number will be up to 260 to 360. And the actual consume power, they still require like under 180 watt. Even they ask a lot of performance over there, but they still need to keep the power under certain envelope. So they're still asking for like a 180 actual usage power. Not everyone can afford like a huge core data center because they consume a lot of land space, consume a lot of power, and they need to be located in the remote area, right? So for the small cities, small populations, so probably a regional mid-sized data center is also needed and growing at this point. So for CPU standpoint, they probably ask for this core count is between 64 to 96 cores. And the performance is required like 250 or up to the 210. Then the power is contained at like 90 watt to 150 watt. Okay, then come to the age and the device. Always the reason because the power efficiency and the reduction of all the power usage over there in order to do the emission reduction over there. Okay, so that's how we see this compute and cloud to the edge. All right, talk about the so-called our daily life, right? So what's happening when we use our service? Like me, okay, this Saturday, my plan is okay. I'm gonna sit on the sofa and then turn on my device. I'm going to select a movie to see. Right? Then what happened during the your end device, and a lot of things are happening in the background in the data center. So let's see, okay, you are interfaced with your web page. So it's a web application. So you see a lot of selection over there. While that in the background, there's AI, because while you see, they will suggest you the movie based on your previous viewing. So they will recommend or suggest a different movie title you can see. So that's involved AI running in the background. Meanwhile, database also, right? Your user name, password, your financial data all stored in the database. Also the movie title, all of that is also in the database, right? And in order to have the excellent user experience, in-memory cache is very important because all the quick data need to install the memory, and you can quick access to that, right? So in the meantime, while you are looking for, you click the button and you select a movie, the media encoding is happening at the cloud. Then send over to your device and the decoding in your end device. So everything is happening in your daily life. So that's the modern cloud workload happening every day or every second. So also for cloud gaming, right? And you play your game while you are on the metro or on the bus. So that's the normal user behavior. So everyone is doing that. So server requirements become more and more. Right? So then just talk about normal user, right? And right now we are the CSP provider, which is a cloud service provider, what they need to take care of all the requests over there, right? So still they're looking for performance per dollar, right? That translates into if I can provide with the limited resource and the limited capital expense, how I can fulfill all the service over there and giving every user a very good experience. So that's why they kind of asking for the very density efficient computing in their data center. Therefore, they need to look for the new technology and new processes to meet those needs. Okay, so that's why Ampere Computing is deciding the so-called cloud native processes to meeting all the needs over there. Okay, so let's look back and all the services that analyze the modern workload over there. So at this point, every second there's 1.3 million requests. Okay, send it to the server, data center. So rack means okay, there's a rack and then how many server that we can put into over there. Usually it's like a standard 42U and you can insert like 30A something server into it. So that going to translate. So how many server or rack they need to put into over there in order to provide the service. So then look further down for the real workload over there. So what's the comparison and what over there then in terms of our processor versus legacy devices. So this below here is like Nginx, Radius, Min Cache, and MySQL. The Nginx is for the web service. Radius and Min Cache is for the memory caching, and MySQL is database. So if we use the gray one, actually it's a legacy device provided by a company, they are 100%, then our CPU can provide like 4.8 times better performance than that. And so for the Radius, Min Cache, and the MySQL, so we can provide a very excellent, good performance and energy efficiency for all the service layer. So what does that mean? Translate into the, okay, let's see from the physical CPUs. If I want to take care of 1.3 million requests every second, how many CPU gonna need for that? So if we use our new technology, our Ampere CPU only require like 36 CPU, but in compare with the legacy, they probably require 82 process over there. So which means a lot of cost, but not able to achieve the needs. So we have like a 2.5x more performance than rack, okay, in a rack. Then translate to the power, okay, we consume like a 12.7 kW power. Instead, they consume many more, like 2.8x times with the legacy device. So therefore, looking to the physical rack needed, if we only require one rack, then the legacy probably will ask for 3 racks. That's really a lot. So on the other hand, if they can put like a 3 rack using our technology, actually they can service like a triple, which means 3.9 million requests per second, which is a lot. So actually for data center service and provider, they actually can save a lot of money because they can save the length, they can save the power, and save the space, which they can do more with this, okay? So which means if they consume less power, then which means this CO2 emission. Okay, so furthermore, we kind of talk about the translation efficiency to the CO2. So from this scale, you can see the left-hand side is embodied CO2, the operational CO2. Embodied CO2, which means if you want to stop something, okay, for example, data center, the new structure, they need to transport all the needed material, including like rebar, and all the concrete, all of that. To site and build up. So that will generate a lot of embedded CO2. By the way, data here shows that the concrete contribute the 7% of the CO2 emission. Okay, in the world, so quite a lot because we use a lot of concrete for all kinds of building. Then once the building finish, then become the operational CO2. Which means it start using the power to do all the server CPU computing works. So operational CO2 will be less for many years, right? Therefore, how to reduce the operational CO2 become very critical. Then you can see the right-hand side of the scale. because the renewable energy, for example, like use the water power, use the sun energy, those are very kind of slow actually, and the efficiency is not so good. So, and it takes a lot of effort. So it's gonna be take a lot of years to have more improvement over there. And also there's a measure for the CO2 offset, which means you can buy the CO2 certification, buy the green power, all kinds of measure to kind of balance each other, right? So that's the current situation. So for a mid-sized data center, okay, they give you the data here. So they're gonna consume 100,000 square feet of total space. They will eat up like 66 megawatts power, and probably can afford like 4,000 racks over there. And per rack is gonna take like 16 square feet space. And PUE is the power usage, which means the ideal ratio is 1. Okay, so if you can cross the 1, that would be meaning for the power saving. But usually 1.2 is very good because all the power used on the compute. Besides that, you need a lot of power to do the thermal because of the CPU is getting harder and harder these days, right? So, which means if we can do all the things, so probably can reduce the CO2 emission by like 50%. That's the goal. All right, the more details here that if compared to legacy device with the computer solution. So legacy device like two company, they kind of contribute like 334 metric tons CO2, and the other one is 270. Then we are contribute 134. So we kind of a 50% reduction over there. So which means for the embedded carbon, we also do the reduction over there. So which is 1/3 of the requirement over there. Okay, if we can do all of that, and we try to do the path to the net zero, right? So by reduction of operation CO2 saving and embodied the CO2 saving, so that way is lighter, so the scale can go up to that way. So then this side from the renewable energy, right? So there's a lot of measurement we can do by using the government can do a new regulation over there, and there's you can purchase PPAs, purchase a new renewable energy like TSMC doing this right now, and also from the peer pressure. Peer pressure means if I pay $10 today, the other one pays $6, then I'm kind of $4 behind, so I need to catch up with them as well. So in that way, we are hoping that the CO2 emission can be balanced pretty soon. Okay, this is from carbon equivalency over here. If we can do some reduction over there using the new technology, we probably can save like 200,000 metric tons of carbon in 1 year, which means if we can save like 200,000 tons over there, we probably need to equivalent like 245,000 acres of forest to absorb all the CO2 over there, or we can take off like 40,000 car run off the road, or 44,000 household powered. Then if we grow up the tree today, right? Then the tree go up after 10 years, they can absorb like this much number of the CO2. So you can see that the growing tree is not really helping immediately, but we still need to do it. But by reduce the data center power usage will help a lot immediately. Okay. So, but we need to change our thinking logic here, right, in order to do this critical mission. Right, because new technology, we need to scale out, we need to scale up in order to change all the things. So hopefully from time that everybody can implement a new technology, So therefore, we can do a lot of good contribution to the CO2 emission reduction. So we have a slogan like this: "Least power is the new power." All right, and finally, Gigabyte. You can see this huge booth here and a lot of traffic here. So a lot of demonstration around for the new technology. So Gigabyte actually is a very strong power of the Ampere computing since the day one we started the company. And also you can see over there showing a lot of assistance, so they can kind of address all kind of user scenario for the cloud computing, for the AI, for the database and edge computing. So if you are interested, you can go over there to see a lot of things. Also, you can go to the website to check all the offering over there. Also, if you are interested in Ampere computing, what we are doing, please check the website to find out what we can do with our CPU. Okay, so there's more if you like to check our lots of website, so you can see all kinds of things over there. You even can access to the doing some evaluation for this our new technology over here. So yeah, thank you. So this my last page and conclude my report here.